Dear students, today let us learn about eddy current. Eddy current is a very small current, and this current is also known as focal current. Now let us understand how eddy current is produced. Now to understand eddy current, we need to understand Faraday's law and Lenz's law. Now remember, in Faraday's law, what happened if this was a coil? This was a coil, this is a coil, and this connected to a galvanometer. This was a galvanometer which could detect small current. And if we brought a magnet having north pole and south pole, if we bring a magnet towards the coil, towards the face of the coil, the galvanometer showed reading. Now, if the magnet is brought away from the coil, the galvanometer again showed reading but in the opposite direction. In other words, whenever there is a change in flux, a current is induced in the coil. The current is induced in the coil and the current is noted by this galvanometer. Now, instead of a coil, if you have a metallic piece, this is a big metal piece, it's a metallic block. Now this metallic block is placed in a non-uniform field or in a changing magnetic field. Now if you place this metallic block in a changing magnetic field, now you know how to change the magnetic field, bring the magnet towards the coil or away from the coil. That is how we change the magnetic field. Now if you take this metallic block in a changing magnetic field, then current is induced in the coil. This current is known as the eddy current. The current is induced in the metallic block itself. That is why it is called the eddy current. Now, this current will move in a direction according to Lenz's law. Now, remember Lenz's law, what happened? When he brought the magnet towards the coil, a north pole was created. A north pole was created in the face of the coil. So, what happened is, when you bring the magnet towards the coil, a north pole is created. When you take the magnet away from the coil, if you take the magnet away from the coil, a south pole will be created. So, direction of current in the coil is given according to Lenz's law, and the induced EMF E is equal to minus of d phi by dt. This minus sign indicates Lenz's law, that if you take the magnet away from the coil, south pole. If you bring the magnet towards the coil, north pole. In other words, opposite pole is created. So this minus sign is given by the Lenz's law. So the current moves in the metallic block according to Lenz's law. So if you place a metallic block in a changing or non-uniform magnetic field, current is induced in a direction given by the Lenz's law. To understand this, let us come here. Now, this is a very good example. This is a coil or a solenoid. This is a source of current with a key, and a metallic disc is placed over the coil. Now, if you pass the current in the coil, the current will first of all increase from say 0 to I. The current increases from 0 to I. Initially there was no current. So when you switch on the current will increase from 0 to I. When the current increases from 0 to I in the coil, there is a change in current, or in other words, there is a change in magnetic flux. When there is a change in magnetic flux, this is a metallic disc. This metallic disc is placed over the core of the electromagnet. So this becomes an electromagnet, and this metallic disc is placed over the core of the electromagnet. Now, when the current moves or current changes in the core, then the current changes in the electromagnet. So a magnetic field also changes. In other words, there is a change in magnetic flux. When there is a change in magnetic flux, suppose a north pole is created here. According to Lenz's law, a north pole will be created on the base of this metallic disc. When a north pole is created on the base of this metallic disc, two north poles will repel each other, and this metallic disc will jump upwards. So, if you pass a current and the current increases from 0 to I, there is a change in magnetic flux. Wherever there is a change in magnetic flux, a north pole or a south pole is created here on the face of the coil. When the north pole is created on the face of the coil, a north pole will be created on the base of on the lower base of the metallic disc, and two north poles will repel each other, and you will find this metallic disc flying away from the coil. So this is a very good demonstration or example of production of eddy current. Now how this north pole is created here, and the south pole will be on the top. The north pole is created on the base, the south pole is on the top. In other words, the current, remember while we are doing electromagnetic induction, I told you that north pole will be created when the current moves in the anti-clockwise direction, and a south pole will be created. This is the south pole. The south pole will be created when the current moves in the clockwise direction. Now I hope you understand in which direction the current will flow. So if it is south pole, then the face in the coil, the current will move in the clockwise direction. So this is all about eddy current. So in the end, what we can say is that whenever a metallic block or a metallic plate is kept on a changing magnetic field, a small current will be induced, and this small current is called the eddy current. Now, eddy current is found everywhere. If you have a transformer, then if you have a transformer and you use the transformer for some time, you will see that the transformer is getting heated up because there is changing magnetic flux. So, eddy current has many disadvantages. One of the most disadvantage of eddy current is that it produces heating effect. Whenever it produces heating effect, this metallic block will get heated up whenever eddy current flows in it. So, whenever heating effect takes place, there is a loss of energy. So, this is one of the most important disadvantages of eddy current. Now, there are some advantages of eddy current also. For example, we can use this eddy current for heating furnace, or we call it as induction furnace. In induction furnace, I hope all of you have an induction heater at home. The induction furnace is based on this principle, that whenever you change in magnetic flux in a metallic block, heating effect, eddy current will move, and correspondingly heating effect will take place. And when heating effect takes place, you can use it as a furnace or induction furnace. This is one advantage of eddy current. Another important advantage of eddy current is that you can use it as a speedometer of an automobile. Now, in automobile, what they do is they place a small magnet, or they place a small magnet on the axle of the car. Axle of the car. You understand the axle of the car? The axle of the car, you place a small magnet. So when the wheel rotates, there is the magnet also moves around it. Whenever magnet moves around it, there is change in magnetic flux. And whenever there is a change in magnetic flux, I told you, eddy current will be produced in some conductors or in some metallic disc. So that small current is connected to the speedometer. So whenever the axle moves fast, more current is produced, and the speedometer shows more deflection. Whenever the car moves slowly or the wheels move slowly, small eddy current is produced, and so small deflection indicates less speed of the car. That is the advantages of eddy current. Now, eddy current, as I told you, heating effects takes place, and this leads to wastage of energy. Now, how to minimize eddy current? If you open a transformer, you will see the transformer core is made up of some metals. This is a metal, say, this is a metal. So, whenever I discuss transformer, we will discuss it in details. Suppose you have a metallic piece, say, for example, and if there is change in magnetic flux, a large eddy current will move around it. A large eddy current will move around it, and so this eddy current will lead to wastage of energy. Now, what to do is how to minimize eddy current. To minimize eddy current, this whole metallic strip is cut into small pieces. This is cut into small pieces. This is cut into small pieces. And cut into small pieces and then laminate it. Now let me give you an example. Say you have a piece of a bread. You have a piece of this is a piece of a bread. Okay? This is a piece of a bread. Now you cut this bread into slices. Okay? You cut this bread into slices. Now what you do is you take one of the slices. This is one of the slices. You put some butter here or jam here. Okay? And then you put another slice on top of it and then fix it. This jam or that butter, what I am saying is now, is lamination. Lamination means does not allow current to move from one part or one piece of the bread to the other. So what we do is we cut into pieces and then laminate all the pieces together, so that we get the whole metallic piece, but eddy current runs in the small pieces. This is one piece, eddy current will run here, eddy current will run here, run here, run here, but not in the whole metallic disc, not in the whole metallic block. So it will run in small parts, and so small current is induced in each of the parts. Otherwise, if you take the whole metallic disc, large eddy current will flow. That will lead to a really good amount of wastage of energy. So here, only small parts of energies are wasted. So this is how we laminate and join all the metallic pieces together. This principle is used in transformer. So this is all about eddy current in brief. So in the next classes, we'll continue about induction. Thank you.